So let us see the next code, which is minimum jumps to reach the end. You are an array, you given an array of non-negative integers, and each number tells you the maximum number of steps you can jump forward from that position. If element of I is equal to 3, you can jump to the index I plus 1, I plus 2, or I plus 3 from the position I. And array of I equal to 0, you can't jump forward from that position. For example, take this array, which is 1, 3, 5, 8, 9, 2, 6, 7, 6, 8, 9, right? So for first jump, it goes to the second element, because jump is 1, right? From second element, your value is 3. We can do 3 jumps. So you can move to the 5, 8, 9, which is fifth element. That is the value of 9. We can move to the 9. From ninth element, we can go 9 jumps to get out of this array. Means you can step on the last step. 9, because the remaining elements is 1, 2, 3, 4, 5, 6. So you can go out of these steps. So how many steps you are doing? Uh, First step here and second step here. It goes from 3 to 9. The next step is here from 9 to. There are 3 steps, right? 1, 3, 9. So minimum jumps to get for the last jump to the last step is 3 jumps. Same from this output, first value, from this input, first value, it goes to this value, and 4, you can jump to the last step. Exactly to the last step, or get out of this array. Anything is possible. So here, the possible output is 1, 4, that is 2. For this element, the first element is 0. 0 means 0 steps. We cannot go further. That means simply you can return -1. That is the code. That is the question. So let us see the code. So we need to take two inputs, which is size of the array and the array elements. As you know, we can take user input from the user. So by using scanner class, we create an object for the scanner class by using scanner system.in. This is a syntax to use to is used to get the user input from the keyboard. So by using this object, we can get any data type. Here next int means we can get the integer value from the keyboard and assign it to the n value. And we create an array iterating to the n number of elements, and we assign the every value to the particular array address. ARR of I. See, the first element is 0, then there is no further steps, right? So that's why we solve that test case here only. If the first element is 0, then 0, we can simply return 0 and return the void. We can simply return out of this main function. It does not execute all these steps, right? So what are all these steps? What are jumps, current, and forest? So before going into the code, I can simply explain what is what exactly code was did to these other test cases. So we are calculating the number of jumps. That is the output. We should return it as an output, and current end where we are at currently, and forested means what was the next forest next forest uh, step or distance. So what we are doing is we are simply iterating to the array, and we are calculating the next forest step from that position. If that position equal to current end, and we are adding the jump plus plus. By explaining this code, it's not possible. So what I did, I simply take one test case to solve this answer. So assume that a simple test case. 143267. 143267, right? This is the array they are giving. So we have jumps variable and current variable, current end, and one more is forest, furthest. That means All these are assigned to 0 initial. So whenever we are at this position, you check what we are doing in first farthest variable. That means far element. That is math.max of previous far element plus I plus array of I. What we are doing is, what was the I value here? I means simply the indexes. That is 1, 0, 1, 2, 3, 4, 5. These are the indices. That is I. For first iteration, for I is equal to 0, the for furthest value will be 0 plus area of I. Area of I means 0 plus 1. So what was the possibility? That next possibility is the immediate element. That was the first element. That will be the, in every test case, that will be the for element. That was the next element we need to check for every test case, because we are starting from the initial element only, right? So next farthest element will be 1. Okay. If this farthest element is equal to this one, equal to I, this one. Is it possible? The first iteration I will be 0 and farthest element will be 1, right? Check code. We are checking I is equal to current end, because current end is equal to 0. I is equal to 0. So I is equal to current end. So I value 0 and current end value is equal to 0. So what we are doing, we need to jump. We have a possibility to jump on that step. So we are doing jump plus and current end is equal to furthest. So what we are doing, we have a possibility to jump from I, because I is equal to current end. So we are assign the furthest value to the current end, that is 1, and we are incrementing the 1. Every time check that current end is get out of the length of the array. That means current end greater than or equal to n minus 1. Every time we need to check, because sometimes in previous test case you can see that 9 is the big element and we can get out of the length of the array. So you can simply check that and simply return the jump and return the void. So you understand for the first iteration, right? For next iteration, what was the possibility? For next iteration, I is equal to 1. What will be the farthest value? Farthest value is equal to max of previous farthest. Previous farthest was 1. And present farthest is what was the present farthest? I plus array of I, right? What was the array I plus array of I? I value is 1 and array of I value is 4. So farthest will be becomes 5 in this place, because we want max. Okay. Now check that uh, I value. I value is equal to current end. So I value how much? 1. Is it possible I value is equal to current end? Yes. Current end also value of 1 and I is also value of 1, which is equal. What we are doing, we are jumping from this position to this position, this position. We are taking this element, right? With this position. So we can update the current end as 5. I hope you understand, right? And jump plus 1. So we are doing two jumps from here to here and from here to next element. From here to next element means we are going to this element. Okay, I hope you understand. So what and for next iteration, check next iteration is I is equal to 2. I is equal to 2. What was the furthest part? It max of previous furthest, that is 5, and also I plus array of 5, right? I value is 2 and array of I value array of 2 values 3. So 3, that is 5 of 5. Max of 5 of 5. It still remains previous max, that is 5. So still farthest equal to 5. And check next element is 2. Check check that. And also we need to check that we need to have a jumps here. I is equal to current end, right? So I is equal to 2, current end is 5, not equal. And next iteration, I is equal to 3, I is equal to 3. What will the for element will become max of previous for and present for. Present I plus present farthest element, right? I plus array of I. So present I is equal to 1. What was the third element? That is 2. So that is 2. So max of 5 comma 5 will be remains previous max, that is 5. And still I is equal to 3, and also current, which is not equal to the current end. Current end is 5, right? 5 not equal to 3. Okay. For I is equal to 4, what will be the farthest? Farthest will be max of previous farthest and I plus max of array of 5. And max I 5 minus I is 4 value, and element of that index is fourth index is 6. So 6. So farthest will become 10, right? Uh, so 4 is equal to current end, right? I is equal to current end. No, still I is 4 not equal to current end. Current end was 5. So next iteration, I is equal to 5. What will the farthest value? Max of previous farthest, that is 10, I plus array of 5. I value is 5. So 10 comma 5 plus array of 5. So what is array of 5? Array of 5 is 7, right? Array of 5 is 7. So 10 comma 12, that is max value is 12. It is stored in the 12. Okay. But still I is equal to 5, right? What happened here? I is equal to 5. Wait a second. There is no we in this problem we don't need to check for this test case we don't need to check uh, further elements, because we already met that current end is already greater than equal to minus n minus 1. So element is 6, right? 6 minus 1 is 5. We already current end is met to 5. But for explaining this part, how the iterations and farthest element was changing, we need to discuss, right? That's why I need to discuss here. Still I need to check that 5 is equal to current end, but we already met at this part. At this part we already met, right? At jumps equal to 2, this part we already met that current end is 5, which is greater than n minus 1. Whenever the current end is changed to 5 here, farthest element, at that position we are simply returning jumps. That is how many number of jumps to. If there is no something like this part, there is no possibility of entering into the last step. We see we can simply return minus 1. Okay. I hope you guys understand it well. If you are not understanding, try to do some dry run on this code. Then you will definitely understand what I am telling. Because these logics are uh, understand by doing only dry run, because these are not getting immediately while reading the question, these parts. So we are calculating farthest element and the current end and jumps. We are creating three variables, and farthest element is the next position where what are the number of steps we need to take to get the next element. That was the stored in the farthest element. And current end, we are already reached to content previously. That was stored in the current end. We jump to the step, and that is we jump to the farther step, and farther step was saved in the current end. And in that situation, the current end is greater than or equal to n minus 1. As it see previously, 5 you get 5 was greater than or equal to n minus 1, right? So we can simply return the jumps, number of jumps, and simply return the void. Okay. Just do dry run on this particular logic while doing this problem. You can understand it better. Okay. I hope you understand this logic. Thank you for watching.